Okay, number 8. The fourth root of 3 minus 8x squared equals 2x. What was the first thing you wanted to do here, Henry?
Put both sides to the power of 4.
Very good. So we'll do the fourth power to both sides. So the fourth power cancels the fourth root, leaving me with just 3 minus 8x squared. And then 2x to the fourth is going to be 2 to the fourth times x to the fourth. So that's 16x to the fourth. And now to solve this, I need to get it to equal to 0. So I'm going to add the 8x squared from both sides. And then subtract 3 from both sides so that I'm equal to 0. And now this isn't a quadratic here. This is a degree 4 polynomial, right? But it only has 3 terms. And if you look closely, this is still in the quadratic form because I have a degree 4 term, a degree 2 term, and then a constant term. So I can still kind of factor this one like a quadratic. So since the leading coefficient isn't 1, my first goal here is to find 2 numbers that multiply to give me negative 48, and then add to give me 8. So if you think about that for a minute, you'd probably settle on 12 and negative 4. We'll do that. So I'm going to replace the 8x squared with a 12x squared plus negative 4x squared, and then make 2 groups. From the first group, I notice there's a greatest common factor of 4x squared, leaving me with 4x squared plus 3. And from the second group, I notice that there's a greatest common factor of negative 1, leaving me with 4x squared plus 3. And if I compare these 2 terms, I notice that they both have the 4x squared plus 3 in it. So I can factor that off, leaving me with the 4x squared minus 1. Okay with that so far, Henry?
Wait, how do you do that? So like how do you go from the 4x squared and parentheses 4x plus 3 and get 3?
So if I look at this and then this as 2 separate things, they have a factor in common, the 4x squared plus 3. So when I factor that off, it goes there, and then the stuff that's left is the 4x squared minus 1. Does that make sense?
Yeah.
Okay. So now that I have it in factored form, I can solve this. So I can set each of these equal to 0. And each of these is a quadratic equation to solve. To solve a quadratic, we can either try to factor, use the quadratic formula, or solve it directly. What's going to be the easiest choice in this situation? So I would solve it directly because each of these quadratics has no x. They just have x squareds. So I can just move everything to the other side and square root both sides, right? Is that cool? So for this first one, we'll subtract 3 and then divide by 4. And then when we square both sides, we get x equals plus or minus the square root of negative 3/4, right? What does it mean when I'm square rooting a negative? It means it's imaginary, right? So this one I'm going to discard as non-real. We're not going to worry about that solution because we got an I. I'm just going to discard that. Now we'll move on to the other equation. So I'll do the same thing. I'm going to add 1 to both sides and then divide by 4. And then when I square root both sides, I'm going to get plus or minus the square root of 1/4. So when I square root 1/4, the square root of 1 is 1, and the square root of 4 is 2. So this gives me two answers, -1/2 and +1/2. Henry, are you okay there? Okay. So now the last thing I have to do is check. So if I go and I check this, the -1/2 isn't going to work, but the +1/2 does. And again, I'm going to just check that by plugging that number into the original and seeing if the two sides match. Do I need to show you that, or are we good with the checking? You take my word for it? Okay. So that was a tricky one, right? We had to pull out a factoring technique that we hadn't used since first semester. It's been a minute since we've tried to do that. But this is part of the reason why these polynomial solving techniques are so important, is many of these other kinds of equations end up turning into solving a polynomial equation, which is why we spent so much time on that topic, is it comes up over and over and over again. Anyways, there are a bunch of other hands I saw earlier. Nicholas, did you have one? 11? Okay. Thought I remember seeing you had a hand up. Okay. So here's 11. What did we want to do to start? Yep, I would square both sides. And the reason I would do that is because one of the two square roots is isolated, right? So if that wasn't the case, I'd want to do that first. But here, the square root of x plus 5 is all by itself. So when I square that side, the square root cancels, and I'm left with just the x plus 5. That's not the case on the other side, though, because I have this stupid plus 1 rattling around in here. So what are we going to have to do to square the left-hand side? Here we have to FOIL. So I'm going to write this like a FOIL problem. Okay with that, Nick?
Yeah.
Okay. So when I multiply the firsts together, I get square root x plus 8 times the square root of x plus 8, or the square root of x plus 8 squared. When I do the outers, I get 1 times the square root of x plus 8, or just square root of x plus 8. When I do the inners, I get the same thing. And when I do the lasts, I get 1. Okay there? So I notice here the square cancels the square root. And here, these guys are the exact same radical. So when I add them together, I can add their coefficients. So I'm going to have 3x plus 8 plus 2 square root 3x plus 8. Okay to there? Okay. So what I'm going to do now is I'm going to isolate the radical for 3x plus 8. So I'm going to subtract this 1 over. Also got to subtract this 8 over. And I got to subtract this 3x over. So when I do that, I get negative 2x minus 4. Okay there. And there's still one more thing to do to isolate this radical. I still got to get rid of that coefficient of 2. So I'll divide both sides by 2. So negative 2x divided by 2 is negative x. And negative 4 divided by 2 is negative 2. Harley? Yeah, so 5 minus 1 is 4, and 8 minus 4, or 4 minus 8 is negative 4, right? I think I copied that all down, right? Yeah. What? Whatever. This is right now. Maybe it was a mistake before. Madison. We're going to right now. Yep. Now we finally got that. We have to wait to do that until we have the square root by itself. Because if we square it before then, we're going to end up having to FOIL again. We don't want to do that, right? So that's why we're getting that square root all by itself, and then we're going to square. Okay? So that is the next step, is to do that. So the square cancels the square root. And then here, I'm going to have to FOIL. So that's going to give me x squared plus 2x plus 2x plus 4x, or 4. And if I combine my like terms, I have x squared plus 4x plus 4. And let's move everything over onto one side. Oh, guys, I see the issue. All right, so time out here for a minute. Everybody's gonna get angry. Don't get so angry. So this was supposed to be minus 8 here. So it's not like this was a lot of mistakes here, right? So I feel so stupid. You ever copy something down wrong and just like it ruins your whole life? Yeah. All right, we're finally back on track here. Oh, shoot. Almost. Okay. All right. So after rewriting that all, now I can solve this quadratic. Stop talking, please. To solve this quadratic, you can either factor, use the quadratic formula, or try to solve it directly. Since there's not just x squared, I can't solve directly. Can I factor this? Yes, how does it factor? Good. Negative 11 and negative 4 are going to multiply to give us positive 44, but add to give us negative 15. So when I set each of those pieces equal to 0 and solve, I get positive 11 and positive 4. I then need to check those. 11 fails, but 4 works. Nicholas, does that feel okay?
Yeah.
Okay. Sorry about making a mess out of that and copying the problem down incorrectly to start with, but the idea was good. Hardly. Sure. So 11 and 12 and are almost identical in that regard, right? So let's see if you guys can help me with the process, and I'll carry out the steps or whatever. Let me double check and make sure I copied this down correctly this time so I don't repeat my mistakes previously. Looks good. What should I start with? Square both sides. Okay. On the left-hand side, what happens? Yeah, they just cancel. On the right-hand side, what happens? We have to FOIL. Good old FOIL. Okay. So, square root of x plus 2 times square root of x plus 2 is just x plus 2. Notice that we're just going to shortcut around writing the square root of x plus 2 squared and canceling the square root and square root. And then square root of x plus 2 plus or times positive 1 is square root of x plus 2. Same thing. And then obviously 1 times 1 is 1. Okay. Let's combine some like terms here. Everybody good there? Okay. What do I do next? Olivia? So 2 plus 1 is the 3. And then there's the x. Is that good?
Yes.
Sierra?
For the next step here, you want to make the left side 0?
Not yet. I want to, not until I've gotten rid of the radicals. So I want to get rid of the radicals before I make it equal to 0. Not yet, because the radical's not by itself. I wouldn't divide by 2 first. I would worry about the x plus 3 first. So let's subtract an x over and subtract the 3 over. Okay with that, guys? And then Madison will divide by 2. Okay there? And I'm just going to leave this as a fraction since the 2 doesn't divide the x evenly. I'm going to end up with a fraction in there somehow, some way. So I'm just going to leave it like that. We okay with that idea? Okay. And now, Sierra, it's time to square both sides. So on the right-hand side, the squared cancels the square root, and we're left with just x plus 2. On the left-hand side, we're going to have to FOIL. Is everybody okay with that? Where did the 4 come from? 2 squared. Good. Okay. So I'm just going to write out that real quick. That's the FOILed. Is everybody okay there? So I just FOILed that out real quick in my head. Who likes this fraction rolling around here? Can we do something about that? Yeah, let's do that. It's a good idea, Nick. So that's going to cancel out the fraction on the left-hand side. Leaving with that. And then, Sierra, it's time to get this equal to 0. So that leaves me with x squared minus 4 equals 0. And then how do you want to solve this equation? Okay, add 4 and then square root both sides. What do we have to remember here when we square root both sides? Plus or minus. And then if you go and check this, I think both of these work. Harley, does that feel good? Okay. So it's a long process, but it's really kind of doing the same solving steps just 2 times in a row, right? You square both sides the first time to get rid of the first radical, multiply everything out, isolate the other radical, and then square both sides again to get rid of that second radical. Madison. Here? So we added 4 to both sides and then square rooted both sides to get plus or minus 2. So like, I did that, right? Well, if there's only x squareds, I can do it this way. If I have x squareds and x's, I can't do this. I'd either factor it or use the quadratic formula. So, Madison, you're asking like a situation like we had back here in the previous problem? Yeah. So here I factored that because I had x squareds and x's. You could have also used the quadratic formula there. That would have been okay also. But if you have no x's, if you have just x squareds, you can just solve it directly. For this one, I took the square root of 4. And because I square root of both sides, that's where the plus or minus came from. Is that okay? Okay. I think we did all the hard ones all the hardest ones from this sheet. Is there more that you guys want to talk about? I'm happy to do some more if you still need some more. Sure. All right. Yes, Justin? Sure. All right, Madison, what's the first step I'd want to do here? Yeah, let's square both sides. So on the right-hand side, what's going to happen? Yeah, the square root cancels with the squared, and we'll just have the 9x. On the left-hand side, what is going to happen? Good. So we're going to have to FOIL that out. Exactly right. So when I do that, that's what we get. Is that okay? Okay. And we'll just combine some like terms here. And then what do I want to do? Good. This is a quadratic equation. To solve this, it's got to equal 0. So let's subtract 9x from both sides. Okay. Now, to solve this quadratic equation that's equal to 0, I have 3 choices: factoring, quadratic formula, or solving directly. Solving directly actually wouldn't be an option in this case because I have x's and x squareds. So I'm choosing between trying to factor this or using the quadratic formula. You could use the quadratic formula in any situation. This is factorable, though. So if you were trying to factor this by hand, you're looking for the 2 numbers that multiply to give you 100 and add to give you negative 29. Yeah, so negative 25 and negative 4 would work. And then to solve this, you can just set each of those equal to 0. And you'd get 25 and then 4. You could also have used the quadratic equation or a quadratic formula there, Madison. That's perfectly fine to do as well. But I think is a little bit more work than the factoring was, if you can see the factors. If you can't see what to do with the factoring, then obviously the quadratic formula is not more work because you're just staring at a piece of paper going, I can't find the 2 numbers that make this work. On this one, I think that they were all factorable. I think I used the quadratic formula when I did number 7 because it had a coefficient on it and I just didn't feel like doing the long factor for it. But it still was factorable because we got rational answers, so they were all factorable. Now this problem wasn't done, just FYI, Madison. We still need to check these answers. Do you remember how to check? Yeah. Exactly. When you do that, the 4 doesn't work, but the 25 does. Does that feel better? Yeah, it's easy to kind of get lost in it. So kind of the goal here, Madison, is that you want to get these longer problems to look like to this spot and then solve it this way. So the first half of the problem is like getting it to this spot, which is just like 2. Right? We have a radical on one side and some stuff on the other. Right? So the first half of this problem is just whittling this down into a problem like number 2. And then we solve it just like we did number 2. Does that help a little bit in terms of like trying to build out what to do? Is turning like this into like, okay, we do this stuff, and then it just turns into this other kind of problem that I can handle. Is that a little better? Okay. Any final questions from this? Oh my goodness. Fantastic. What I need you guys to do is to take out a separate sheet of paper and your calculator and clear your desks.